Okay, in this video, you're probably going to want to write a few of these units down as we go, keep from having to constantly look back at it. But we're going to talk about some units of electricity, and this isn't all of them, but this is some of the ones you've probably heard of. And I just want you to understand what goes into it. The math here is actually quite simple. It's just understanding what a particular measurement or calculation really means. That's kind of the challenge here. Okay, so the first one to take a look at is called current. An electrical current is something that almost everybody's heard of, but the letter we use in physics to represent this is a capital I. It doesn't seem like it fits, but that's the one that's used, so we'll kind of get accustomed to that. And current basically talks about how much electrical charge is moving through a circuit in a particular amount of time. Now, capital C represents Coulomb, and that's a unit of charge. And this is defined as coulombs per second. Now, that could get kind of complicated to talk about, so in real life, we call that an ampere, or an amp for short. Most of you have heard of an amp. Voltage, capital V, almost everyone's heard of this, but they don't necessarily know what it means. It's defined as a joule per coulomb. Okay, now if you think about that, joule is a unit of energy per coulomb, which is a unit of charge. That can get kind of complicated again. So we call that voltage, volts. It's like potential energy. It's sort of like we talked about in a previous video, it's the oomph behind a battery, how much push it can really provide. Power is defined as current times voltage, okay? And it's also written as current times the change in voltage, okay? Because in some cases, the voltage may go up or the voltage may go down, and we're just looking at that change that it has. If you're talking about a current that has a battery now and previously did not have any sort of power source, then you don't really need to worry about the change in voltage. The original voltage was 0, so we would just think of it as current times the voltage on the battery. Now, that would be in units of joules per second if you go through and actually do your unit cancellation here. And that gets complicated also, so that's known as a watt, capital W. And most people have heard of watts. Okay. The last one here is energy, which most of you have dealt with in different cases. We just haven't seen it from this perspective yet. That is defined as power times time. Now, if power has a unit of time within it that deals with seconds, then this time also needs to be in seconds for this to work out. And we get our seconds cancel out and we just get a unit of joules. Okay, so you have amps, volts, watts, and joules, all meaning something different but all interconnected to each other. Now, that being said, don't forget these are also things that can be used with metric prefixes. So it's possible to have a milliamp, or a kilovolt, or a kilowatt, which most of you have heard of. So just keep that in mind that you can have something that's 1,000 times bigger or 1,000 times smaller. That's pretty typical. So treat these as though you would like kilograms or millimeters. All of those things have the same sort of relationship. Okay? So these are some basic units of electricity we're going to use. Now, dealing with them mathematically, like I said, is actually quite simple. It doesn't take long calculations. The challenge is just recognizing what they mean. So I'm going to take a look here and show you a sample problem. And this problem is in your physics book. But for those of you who don't have your books and didn't have them before you left school, I want to show you this so you can at least kind of follow the process. Okay? Now, this says a 6-volt battery supplies 0.5 amps of current to an electric motor. First question is how much power is delivered to the motor? Okay? So we're going to take a look at our power formula, which is current times the change in voltage. Well, before the battery was hooked up, there wasn't any voltage or potential energy hooked up to this current or to this circuit before. So our change in voltage is just 6 volts from the battery. So I'm going to write this out as P equals current, that's what my I is, which is 0.5 amps. Now let's think back to what that amps really means. That's kind of our shortened version. That's what you're going to see most of the time in real life. However, I want you to recognize what it really means. It's a coulomb per second. Okay? So I'm going to write coulomb per second. You don't need to do this every time. I'm just doing this to show you what really is behind some of these units. Okay? Now, we're going to multiply that by 6 volts. Okay? And if we have 6 volts, and we look back at what a volt really is, a volt is joule per coulomb. So I'm going to write joule per coulomb. Okay, once you get accustomed to these units, you don't have to do this all the time. I just wanted to show you where it comes from. When I do this, the unit of charge of coulomb cancels out, and I'm left with joule per second, which is what power means. 0.5 times 6 is 3, and that is joules per second, which really means 3 watts. So I put a capital W. Okay, so this is 3 watts of power that's supplied to that particular motor. Now, go one step further. The next one says if the motor runs for 5 minutes, how much energy is used? Hopefully by now you're already starting to recognize things like, hey, power deals with seconds. This tells me minutes. I better get those units at least on the same scale. So 5 minutes times 60 seconds per minute. This is really a total of 300 seconds. And I do not want to deal with 5 minutes anymore. I want to get that accidentally involved in the calculations. So my formula for energy is power times time. So energy is going to be power, which in this case is 3 watts. In this instance, I'm going to write it as joules per second. 300 joules per second, which is what a watt is. And I'll multiply that by, I just screwed that up. It's 3 joules per second. There I go, talking ahead of myself again. 3 joules per second, that's my power right here, 3 joules per second. And I was jumping way ahead of where I was at. It's times 300 seconds. And when I do that, my seconds cancel out and I'm going to be left with 900 joules, or 0.9 kilojoules. And all I'm doing this for is just to show you the transformation between current, voltage, power, energy. It's real easy to get them mixed up. So I wanted you to see that it's very simple math, but just like I did right here, you can easily get off track if you aren't really thinking about what is represented there. And just make sure you include units that go with it. When you use a unit like a watt, try to think to yourself, what does that really mean? Okay. When you use a unit like a volt, what does that really mean? And once you get accustomed, then you start using volts and watts and amps, and you just kind of have that idea. But at the beginning, it's very difficult because some of those ideas are not things you've really been through much before. Okay? So that's our simple way of dealing with power, energy, voltage, and current.